So in the first video, we learned the three trigonometric functions, sine, cosine, and tangent. The purpose behind those was to find missing sides or to find some ratios related to right triangles. Well, there's more going on in right triangles than just side lengths. There's, of course, angles. So we have something that's called an inverse, and you can represent the inverses of these three trigonometric functions three different ways. There's this one for sine, there's this one for cosine, and this one for tangent. And because these aren't, we don't really want to have to say sine to the -1 or cosine to the -1. We, as math teachers, have given these kind of special names. So this one is referred to as the arc sine, A-R-C, arc sine. We have arc sine, arc cosine, and arc tangent. So that's how you're going to refer to those things. Those are simply inverses. And what they're used for is kind of the point of this video. In the previous video, we talked about how we could have sine functions or cosine or tangent that would give us ratios. For example, the sine of theta might be 1/2 if we're just making up an example. Well, the arc sine of 1/2 is the 30. So what we're really doing is we're calculating, I'll take this out and put the number in. What we're doing is we're saying that we can switch these numbers about. So what we'll find is if we know the angle, we can come up with the ratio. That's what we did last time. In this one, if we know the ratio, we can come up with the angle. So what are we going to use these arc sines, arc cosines, and arc tangents for? We're going to use those to find we're going to use those to find angles in a right triangle. All right, so that is the goal of using arc sine, arc cosine, and arc tangent, or the inverse tangents, cosines, and sines. Now, to do this, you're going to rely heavily on your calculator, and you have three different options. Well, you might have more than three, but I found myself not being able to use my iPhone calculator, but I was able to use a couple other options that you have available to you. I believe both of these, the one on the left and the one on the right, are both available in self-service. And then some of you have calculators that are similar to the Texas Instruments. So let me kind of show you where you're going to find these things. First, if you're using this calculator option here, you're going to notice that on the right-hand side you have sine, cosine, and tangent, but those aren't what we want. We want the inverse of each of those. So you're going to have to use the shift button and watch what that looks like. If I open up the app, when I click the shift button, you'll see the sine, cosine, and tangent all shift to their arc sine, arc cosine, or arc tangent. And here's how it would work. The arc sine of 1/2, which is the one we already discussed, equals 30. Now, if we go back to the second option, the calculator option, when you're going to see that, well, one, we have a basic, a scientific, and a couple other calculator options. I've chosen the scientific option, so you'd have to do that same thing. If you select the scientific option, you're going to see sine, cosine, and tangent right here. But up above it, you're going to notice that there's the arc sine, arc cosine, and arc tangent. And to get to that, you're going to, again, need to use the shift option. That shift option is going to be right here. And here's what that looks like. So to get to arc sine, you're going to click the arrow that points up. In this calculator, you actually type in the 1/2 first. So we'll go ahead and do 1/2. And then you hit the arc sine button. Now, when you do that, you get kind of a funky answer. They want to give this to you in scientific notation for some reason. 3 times 10 to the first is what this means. 3 times 10 to the first is just 3 times 10, or 30. Let's go back and check out the last option. If you have a calculator at home, this is probably the easiest way to do it. Well, if you have the calculator, it's easy. You're going to notice that here's the sine, cosine, and tangent buttons, and you're going to notice up above them, there's the inverse. Sine, cosine, and tangent above. Those are in yellow, so to activate those, you have to hit the yellow button first, and then you hit them, and then they type in line. So in my opinion, this one's the most cumbersome to use. I would say two good choices are download from self-service your calculator, calculator number, I guess look for that icon and download it, or if you have access to a calculator, use that one. So those are my two recommendations for using those. So during this quarantine, I've been checking out Facebook, and I've got a number of different groups I belong to. One of them is a climbing group, and I've been thinking, I wonder what the angle of my climbing wall is. That's right, I have a climbing wall in my garage. I'm going to show it to you in a second. But in trying to communicate with the people online, I need to tell them how steep my wall is. Climbers like to measure the difficulty of their wall by the steepness of the wall. If you climb up this way, this is a tougher, steeper wall. Than something that's this, right? If you climb up this way. So I need to measure the angle of the wall, but I don't have any tools to measure it. But we're going to figure it out with a level and with a piece of duct tape and a tape measure and a tennis ball with a string and a little bolt on the end. So using these basic tools, we're going to figure out the angles of my climbing wall. Let's go check it out. Come on. So the first thing that I'm going to do is I'm going to measure 3 parts of my wall. The bottom part of the wall is the least steep. The middle portion of the wall is the second steepest. And this section over here is the steepest of them all. I'm going to measure all 3 of them separately, but I'm going to show you how I'm going to do it. And it's going to start with this. I have a string with the ball. Construction workers would call this a plumb bob. And I'm going to screw this with the string into my wall. All right, so let's find a good spot here. Here we go. All right. Now what you'll see is the ball is going to hang down. Eventually it'll stop swinging around. I'm going to try to help it out a little bit. And then that in theory is aligned straight up and down, kind of perpendicular to the ground. Now hold that thought. The next thing I'm going to do is I'm going to mark, I guess I need 2 pieces of duct tape. I'm going to mark the bottom of my angle and my level, and I'm going to move it up and down until come around here so you can see. You want to make sure that your level is right in there. That way I have a perfect angle. Now I'm going to do this just so. I'm going to mark it here, and you can see that I'm starting to move around a little bit, so I'm going to try not to move around too much. And here. All right, we're going to let that go. All right, you can turn. Okay, so now I'm going to measure how far it was from the wall to my string, and I can do it this way. So from the wall to the string is 29 inches. And we're going to measure how far it is from the wall down to the what do we call that thing? The level. And that is going to be approximately 23 inches. So I have 23 this way and I have 29 that way. We're going to figure everything else out. So let's go ahead and take this first example and work it through. And I'll do this one with you. First, in my image, I drew the triangle that we're trying to find. You can see the angles there. I measured it, and, well, I did some measurements. Here's what I found. From the wall, which is here, to the point where the string and the level touch, which was here, that distance was 29 inches. So I'm going to put 29 inches here. It's going to be a little bit hard to see, so I'm going to put that right there. And then I also measured from the top of the string to the spot where I marked on the string to see how long that was. And that distance was 23 inches. So let's go ahead and put that on there as well. Now, as much as I love looking at pictures of myself, I'm going to go ahead and, for the ease of the question, let's go ahead and, let's get rid of that. Well, maybe I can't get rid of it because it looks like it deletes my numbers at the same time. So we'll just leave it there. And I guess I should point out that I labeled angle theta. The angle that climbers refer to is this angle that's up at the top. It's how steep the wall is. So that's the angle that we're trying to determine. So with that in mind, I'm going to go through the 3-step process that anybody would do in trying to solve this problem. The first thing that I would do is look for what's available. I have angle theta, and from angle theta, I have an opposite side, which is 29, and I also have an adjacent side, which is 23. So I need a trig function that has the O and the A for opposite and adjacent. And my SOH-CAH-TOA, I need opposite and adjacent. Opposite hypotenuse doesn't work. Adjacent hypotenuse doesn't work. Opposite, adjacent, there we go. So I'm going to go ahead and use tangent. So that's how I determine which one to use. And here it comes. I'm going to write tangent of theta, because that's what I want to find. is going to be the opposite over adjacent. So opposite is 29, adjacent is 23. And then what I'm going to find myself doing is using that kind of switcheroo that I talked about earlier, where if I use the arctangent, I can go ahead and switch these values. So now I'm going to do 29 over 23, and that should give me theta. So arctangent of 29 over 23. I'm going to use the calculator option that I prefer. It's this option. I still have the example from last time. So let's go ahead and try arctangent. So shift tangent of 29, and 23. And what should happen is, there we go. So I have a 51.6 degree angle on this portion of the wall. So I'm going to go back to my drawing, and I'm going to go ahead and say my theta. My theta is 50, what did I say that was? 51.6 degrees. And that's how I would type that in. So this time I'm going to do the lowest wall, the one that's the least steep, but I'm going to do this one differently. The way I'm going to do this one is I'm going to measure, get this to stop moving. Okay. I'm going to measure from the wall to the string. Here we go. So I'm going to mark the wall. Like this with the corner of this, with the corner of this piece of tape, a little pointy edge there. And I'm going to mark here. All right. From the wall out to the string was, we're going to round this off, 18.5 inches, 18.5 inches. And from the tip up to the string, and these holds might get in the way a little bit, but from there, we're going to have to use our imaginations a little bit. We're going to say about 40 inches. All right, so 40 inches, and what did I say?
18.5.
18.5 inches. All right, good.
Okay.
Okay, for the record, don't try this at home. This is not a good idea. But we're going to try to measure the third angle here. Okay, measure the third angle here. Okay. All right. There we go. So the third angle is the steepest. It's the one that should be the hardest. So we've done a couple different measurements. We're going to try one more different one this time. We're going to try the string, and we're going to try the wall for variety. So you can see the ball isn't rotating around. I have the bottom of the wall, which is more convenient to measure. And I'm going to do string and wall. So the string, what I'm trying to do with this level and the strings, I'm trying to make a 90-degree angle right here. So that's what I'm trying to do. And I'm going to go from the bottom of this piece of tape. This might not be perfect, but it's going to have to be good enough. Oh, I messed it up. Try this again. There we go. All right, so the bottom of the piece is tape. So here to up. And now I'm going to measure. All right, now I'm going to measure two things. The string is 17 inches. And from where I put my tape measure on up to the base of the string is 30. It's going to be about 33 inches. So we have 33 and we have, what did we say, 17?
17.
33 and 17. All right. So let's go do some calculating.